to get going.
Sure.
Because the fact that your batch hasn't started does not mean you're idle. So there are things you have to actually get started doing right now.
Okay, that's fine. I appreciate that.
Okay, cool. So like I was saying, so just a quick recap from yesterday. What we're trying to do is to simulate a full-blown end-to-end situation where you have tools supporting your continuous integration setup. Ultimately, we're going to have an application that will go through CI/CD using Jenkins. But before we get to that, there are certain things we need to put in place to ensure that we have a smooth operation of our CI/CD. Now, DevOps is not about tools. That's what a lot of people say. DevOps is more about the process, the people involved, the culture, those kind of things. And the ultimate goal for DevOps is to ensure that we're able to release software in a very fast, speedy, agile manner, and also ensure that that software that has been deployed or delivered is of great quality, okay? And that is being driven by a solid CI/CD process. To have a CI/CD process, obviously, you need tools to support it. The application that you're deploying for people to use in production, they need to run on servers. Operating those servers, traditionally, back in the days, you will put them on maybe physical servers or virtual machines, but things are changing really fast. Now we're in the era of Kubernetes and Docker containers and all that. And we don't know what's going to happen in the next future, but currently this is the status quo. Now, to work with Kubernetes, obviously you need to understand the Kubernetes technology. There are other tools within the whole Kubernetes ecosystem that also work together to achieve the same results or the end goal of having a solid CI/CD process. We have Helm, which we use to deploy, to manage releases and all that. So we saw that in action yesterday as well. We have kubectl. That's another tool that does similar thing, but there are use cases of when to use kubectl and when not to use kubectl or to use Helm instead. Now we'll get to a point somewhere down in our journey in the next few weeks where we don't even use Helm, we use something else to then facilitate the whole CI/CD process and making sure that we have a stable infrastructure, one that is secure, one that is highly scalable. And, there's just a lot of things that emanate out of the end goal that we want to achieve, which then leads us to using so many tools. And that's where DevOps become really complex, because you see a job description, then they start asking you, how many years of experience do you have in this, in that, in Linux, Docker, AWS, the list keeps going on and on and on. But what I personally do in my career is to focus on the most used tools, okay, which I am certain out of 10 job descriptions or vacancies, 70 to 80% of the tools I know will be there, which increases my chances. So sometimes you might hear some tools and then you're wondering, which one is this one again? What you just have to do at that point is quickly do a bit of a research. What does it do? What are the alternatives? Which one is used the most? And if you want to learn, then you should focus on the one that is being used the most. So you can trust what we're doing here, that the tools that we're going to be using are tools that are used mostly in the real world. And also, sometimes I tend to introduce certain processes to you, and then later on I say, well, this is actually not the best practice. This is what you should now do. And the reason for that is very simple. If I start showing you best practices, and you don't understand or get to see what is not best practice, it might be it might just not really make sense that way. But having a complete overview of things from both ends then helps you with your understanding of things generally. And the good thing with that also is when you're in an interview where you're speaking to people, you have a broader range of knowledge and you're able to, speak regarding pros and cons of things. Okay. All right. So let's just crack on. So yesterday we deployed Artifactory. Okay. This is the URL. And obviously you saw that we had to talk about Ingress controller as well. The fact that we do not need to deploy Artifactory to use its own load balancer all the time. Okay. And then we went ahead to have a quick look at how the Ingress controller works with the Ingress resource. And then I guess that's about it. So what we're going to be doing today is to, first of all, do another release for Artifactory so that we can disable the load balancer, because now we have the Ingress resource. Actually, let's have a look at that. So if I do kubectl get service in the tooling namespace, we should see that Artifactory still has a load balancer configured. So we're going to remove that and update it to use a cluster IP. Actually, this is Nginx Artifactory. Let's have a quick look. But anyway, so we'll work with that. So we should disable this load balancer. The only one we're going to be using is the Ingress one. And the other thing we'll do is to then configure this host to use TLS. So even though we're talking about CI/CD and all that, all these things have to be in place before we even get the CI/CD itself going. So yes, we have this URL. I mean, you guys can go to this URL now if you like. I've sent it in the chat box. And you can actually, let me go to the URL. So you can then see that it's not secure at the moment. Okay. All right. There's something I would like to quickly test so you can see. So, right. Okay. So I put HTTPS there. Even though we haven't actually configured HTTPS, it looks like it's able to work with HTTPS still. If I look at this right here, it says not secure. It actually shows me that there is a certificate that is being used. So if I click on this, what you would see is Kubernetes Ingress Controller Fake Certificate. It is a self-signed root certificate. It has its own expiry and all that. If I go into the details, you can see that it's actually a certificate that's been issued by the Kubernetes Ingress Controller. So what this goes to show is every time you deploy an Ingress resource, like we did here, okay, even though we haven't configured the TLS aspect, it actually works with TLS out of the box by default. And that's because if we, let me see if I still have that command. If I exec into the Ingress controller and go into its configuration, you would see that it has a default configuration for TLS, even when you do not provide a TLS configuration. And for those who are hearing TLS for the first time, it is a protocol that ensures that we have secure connectivity when we are using the browser. It's actually a new age of SSL. So if you have heard about SSL, it's exactly the same thing. It's just a more advanced, a recent version of SSL. Okay, so let's go into our nginx.com. And if I search for TLS, you can see that it has some TLS configuration. So if you scroll down, you can see there is all sorts of TLS. So you see SSL, it's basically the same thing. So it does have TLS configuration. You can see there's a path to the private key and the private key and the public key. And sure enough, even the name is called default fake certificate. So that's the one that is showing up here. So the moment I put HTTPS in there, it just defaults to that certificate. Okay, so that's a very important thing to bear in mind. The reason this is important is so that in the real world, you may be asked to, you may be faced with the task to actually configure ingress for TLS and things like that. And when you're testing, you are able to see that actually it's able to, because you can click on to actually proceed and hit proceed to Artifactory, and it will sure enough lead you to that site based on HTTPS. So don't confuse the default certificate settings with the one that you're actually supposed to configure. Okay, so that's a very important thing to be aware of. Okay, again, my internet is still very bad, so I apologize for that. All right, so the next thing I would like us to do is to now, actually two things. So we're first of all going to disable that load balancer. So let's go into the values file. So you can see here we have service load balancer type. So let's see what this section belongs to. So I'm going to try to trace this up. So this is service, and I guess Nginx will be at the top. Okay, yeah, it's Nginx. So that's the reason, because when I did a get service the other time, it was showing that the Nginx that Artifactory provisions is using the load balancer. So Artifactory is using this Nginx as its own reverse proxy. So don't confuse it with the Ingress controller, okay? This is a standalone application that Artifactory is using just to do some configurations for, like, you're going to be creating different Docker repositories. So you can actually configure, like we have, for example, let's go to the site. So, like we have here, artifactory.masterclass.tooling and things like that. Maybe another team is using this same Artifactory, and then let's assume the DevOps team. Okay, let's say, actually, let's not use DevOps team. Let's use maybe finance. Okay, in your company, you have finance.docker, something like this. So rather than do all this host configuration in your Ingress and all that, Artifactory has the functionality where you can do the configuration to do all that. But I don't generally use that, so I just disable it. So you can either just disable this Nginx completely, okay, and work with your Ingress. So you can actually set this to false. But before I do that, let's set this to cluster IP. I'm trying to look for that load balancer. Okay, here. So let's set this to cluster IP. So for those who have been learning Kubernetes, this concept will not be new to you. You would understand the difference between all these different service types. Yeah. Okay, so let me get my values. Well, okay, factory value. So remember, this was a command I ran yesterday, which was to set the location of the values. And then I will run Helm upgrade. Okay. So I'm going to run Helm upgrade now. And every time you're running the Helm upgrade, again, remember we had that problem initially, which gave us the suggestion you have to set the database upgrade true. The reason for this is just how Artifactory works, because if you don't set this, it will try to connect to the database, and it just throws all sorts of errors in the log. So once you set this to true, it doesn't bring all that problem. Okay, so while we're waiting for that, let's try to log into this. I think I have the password here. Okay, so we haven't really completed our configuration. So for now, I will just set this to HTTPS because we're going to configure this for HTTPS anyway. So let's set that. We're skipping this. Okay, so this was where we stopped yesterday. We're supposed to create repositories. So I wouldn't want us to start going into that now. So what I will do is I'll skip it, because if I click on what repositories I want to create, like Docker, and then select Helm, okay, it will do all the heavy lifting. But I won't do that. I'll skip it so that we can go through the manual steps to create those repositories so you understand exactly what's happening. So congratulations, let's finish. Okay, let's see, this is still running. So apart from the fact that Artifactory itself takes a bit of time because of a lot of things it has to do, my internet is one of the factors. All right, so this is the UI for Artifactory. If you go to repositories and click on repositories, it has an example repository here, generic, you can store anything there. Traditionally, this tool was used to push your build, so for example, if you're working in a team and they're using Java as their programming language, when they build the application into a jar file, you can use Artifactory as a place to store your artifacts. Okay. So, but with the fast and dynamic changing of things in the tech world, this company, JFrog, is also able to pivot into a whole lot of things happening in the industry. So you can see quickly they've introduced working with Docker, working with Helm. Everyone is just going in the direction of where the industry is going. Okay, so no one really use artifact tools like this to store your jar files or your application binaries. Okay, because most of them are now, especially the modern ones, are now packaged in Docker images, which you can then push here. But of course, it still works with the traditional one anyway. So if you still want to store your artifacts there, that's fine. Okay, so this has run the upgrade. So let's run get service again and see if that has been sorted out. Okay, right. While we're waiting for that, the next thing I want to talk about is going to be how we are going to implement SSL. And anything we do, we have to think about the long term. It's one thing to deploy an application, and we can probably just go ahead into some websites and say, oh, we want to buy an SSL certificate. Okay, there's a lot of providers out there. If I Google SSL certificates, maybe purchase or something like that. Okay, you would see that there's a lot of people that provide this service. Okay, all right. Looks like we still have the load balancer there. So did I actually save this file? Yeah, let's see. All right, let's see if there's another. Okay, there's no other load balancer. Wow. Okay, let me check this. So I'm going to do kubectl, ctl, edit service. So I'm going to edit this service to understand if that change was considered. Okay, so as you can see here, there's DigiCert. These are Google ads saying, "Oh, come buy certificates from us." All those things. But what you have to bear in mind is these certificates have expiry. So you can buy a certificate, but the moment that certificate expires, your users won't be able to use your site. You start having errors, anything can go wrong. Okay, so you have to set monitoring in place to ensure that you get alerted when it's getting close to expiring. Some expires every 12 months. It depends on the configuration you set. You can set it however you like. Okay, but in the world of Kubernetes, we can't rely on things like that. Um, things change really fast. Okay, you have CI/CD pipelines that are fully automated. Okay, so the last thing you want is to have dependency on things that require manual effort. Okay, because once the certificate gets expired, you have to then go back to the company, get the certificate, go into your cluster, or manually install the certificate. Things like that is not good, is not friendly for CI/CD. So sure enough, there is a tool called the Cert Manager that does all the heavy lifting. Now it has its own learning curve because you can deploy Cert Manager now and be completely lost as to where to start. So what we're going to do is we're going to go through Cert Manager it's been used, and then how it can be used with your Ingress resource to ensure that it can then dynamically provision certificates that will be trusted by your browser. Because it's one thing to have certificates, it's another for that certificate to be trusted. As you can see already, we're on our site. Even though we're using HTTPS, which is supposed to be secure, it doesn't mean it's not secure. It's actually secure. Your traffic is still encrypted. But the problem is your browser just doesn't support or recognize this certificate. And that's why it's saying it's not valid, it's not secure. So it's just because it's not trusted. We'll go through the details of how browsers trust certificates shortly. By the time I start talking about Cert Manager, how it issues certificates and all that, then you get to see how it does the trusting. Okay, I'm having time out here. I am suspecting my network, definitely. But I hope you're still hearing me because I'm going to need a bit of feedback from time to time.
Yes, we can. Yeah, we can still hear you.
Yeah, as you can see, it's even saying your internet is unstable. Can you guys hear me?
Yes, we can.
Okay, thanks for that feedback. Guys, I thought someone was going to spot that. You guys didn't notice that I actually put a wrong thing there. So edit service, it's supposed to be SVC.
SVC. Sorry.
Okay, let me split this so we can have another place. Okay, so we get service. We shouldn't have the balance anymore. We can begin to talk about the cert manager. Okay, apologies, guys. So it looked like the internet got disconnected there. So I'm just going to share my screen back. Okay. All right. I hope you can hear me all right.
Yes, we can.
Okay, thank you. All right. So now, how do we deploy Set Manager into our cluster so that we can make use of it? Before we talk about deploying it, let's now also talk about how your browsers trust certificates. So if you on Chrome, if you open the settings section and search for security, like you can see here, this is the security section, and if you click on it, you'll see the privacy and security tab, which you can get to click on. There's a part below called the manage certificates. So if you click on that, it will pop up something like this. And by the way, this is on Chrome. So with Windows, it might be a bit different experience for you, but you can still follow the same thing because obviously Windows and Mac would have their own ways of keeping their keychain. But on Mac, it would load up all the certificates that it trusts. So what happens is the providers of all these browsers, they embed the browsers with list of certificates issuers that they already trust. So some may already look familiar to you. As you can see, there is an Amazon root CA, and they have CA 1, 2, 3, 4, and all that. So definitely the root certificate of the issuers is being stored within your browser, so that when you start hitting certain endpoints, the certificate that has been issued to be used by that website, okay, what's going to happen is your browser is going to check the root certificate to ensure that that certificate is trusted. Okay. If that is not there, what's going to happen is you will see things like this, not secure, just because it is not aware of this certificate. And the reason why this is not trusted is because this particular certificate is a self-signed certificate. So it's not actually issued by anyone. It's something that you can create your own certificate authority. If you have gone through the Kubernetes from ground up, there's a series of Kubernetes videos that we've done in the past. So I think it's part of the prerequisite that I shared with you guys that you should watch. If you actually went through that, you will see examples of how you can actually build your own certificate authority and issue certificates. So that's an example of a self-signed certificate, because you're issuing those certificates yourself. It's not one that is trusted and exists in browsers. Okay, so that's what's going on. So this is how you get to see. One thing you can do actually is, if you want to start trusting this certificate, there is an option here that says trust. So you can just add this certificate to your browser. So it says when using this certificate. So it talks about when you want it to use. So you can tell your certificate your browser to start trusting this certificate if you want to. So once you do that and you hit OK, it's going to add the certificate to the list of certificates that it already knows about. Okay. Okay. Now let's talk about certificate management in Kubernetes. So one of the tools used in the real world at the moment is Cert Manager. There are other ones. Even Amazon has its own certificates management solution. And I believe there are open source tools that you can actually use with it, so that you rely on Amazon to issue certificates and all that. But the one that is very, very stable at the moment, that is being used in many production systems, is this Cert Manager. It is open source, and all it does is it works with certain issuers. Okay, like in this image you see here, these are different issuers. So it doesn't work with all the issuers. There are specific issuers that it works with. So it works with Let's Encrypt, it works with HashiCorp, Venafi, and these are companies that it currently supports. If you go to the official page of Cert Manager, which is certmanager.io, you will see all this. So if you go into the documentation, they actually have a Slack channel you can join. Okay, right. So it looks like they have added a few more. So I'm going to have to update that documentation, because now they've added AWS, Venafi, Cloudflare, and all that. Okay, which is very good. Apparently, now they now support Kubernetes resources, because what this means is you can start creating your own PKI, which is the public key infrastructure within Kubernetes, and then it will start generating certificates for you, similar to what the Ingress controller has done. Okay. Now, using this, it doesn't mean that your site will be trusted, because obviously it still has to be part of what the browser knows about. Okay. So the fact that you're using this doesn't mean that your site will be trusted. But if you use like AWS, as you can see, there's AWS in the list. I'm sure there's Google as well. Of course, there's HashiCorp Vault, there's Venafi, Cloudflare, Let's Encrypt, and Kubernetes. So with what we will be using is Let's Encrypt, but the setting is very similar. And one thing again is this solution, they have very good documentation that you can follow to see how things work right from the installation. So depending on how you want to install it, you can use Helm to install, you can use a lot of different options. So they have their own CTL tool, CMCTL. I haven't actually used that. But then in terms of configuration, there's a whole lot of things. So as you can see here, this cell sign will represent that Kubernetes I mentioned before. If you have your own CA, because it's possible, some companies, because one thing is when you work with companies, it doesn't necessarily mean that all the applications you'll be supporting are publicly facing. Some applications are only going to be running within the company. Maybe it's a software that they're using within that company and no one else is ever going to use it publicly. So things like that, if I even using a self-signed certificate might just suffice for your need, okay? And you can just deploy that certificate into your browsers. So your company may have their own certificate authority, which they manage themselves, that issues other certificates that can be reissued for different applications that you're using. So it all depends on the setup of where you're working, what works for them, what's their practice, things like that. But whatever the situation is, whether you want to use Venafi, Vault, CA, anything, you can come to the configuration and they will tell you exactly what you need to do, exact code snippets and all that. But what we will be doing is pretty much going to be very similar to any use cases that you may find, okay? And if you go for an interview and the conversation comes around certificates management in Kubernetes, if all you've ever had experience with is Acme, and by the way, Acme is with the Let's Encrypt, which is the one that we will be working with. If that's the only experience you have, it's fine. You're not expected to have all this knowledge. Every sane recruiter understands that what you need is the base understanding of things. If you work with one, it's not going to be a problem for you to work with another. As a matter of fact, in the real world, when you're running in sprints, in agile fashion, there are times that you will be assigned tickets to go and conduct what is called a spike. A spike is basically saying, well, we haven't done this before. We would like to use Venafi, for example. Please go ahead, do a spike on how we're going to use Venafi. So that spike will give you the opportunity to go ahead and do a research. You'll read their documentation. If you like, you can put some documentation together, like a pro and cons, especially if the spike has details about, okay, make a comparison between Venafi and Vault. You can produce the documentation. But of course, that documentation will be as a result of your testing of both comparisons that you're doing, or if it's more than two comparisons, So that spike will help your team to understand the direction to go. And then in another sprint, you can then have a ticket to do the actual implementation. Because then you've done the spike, you understand that these are the pros and cons of Venafi, for Vault, for whatever. And then as a team, everyone can discuss it and say, okay, well, we think that Vault will work for us. Not because Venafi is not good, but because we're using Vault in other places already. Why do we want to introduce something new? So let's just use what we already have. That could be the reasoning behind making a certain decision. Okay. One of the reasons that I know that some companies will not use Acme is the fact that to retrieve certificates, it has to go through the internet. So if that is a requirement that we want to manage certificates within Kubernetes, but we don't want to go to the internet, then this rules out your option. Okay? You can't use Acme because with Acme, let's go to the documentation actually. So with Acme, you can see that it has to go to this site to retrieve the certificates. Okay. Now, you may configure some proxy and do some kind of mirroring and all that. But what if you don't have the time to do that, or you don't have another team that can do that, or maybe there is so many processes in the organization because it's so big, it's a different team that has to do all that proxy configuration, and it probably take them another 2 months to get it ready because it's not there in existence. There can be so many reasons why you would want to do one thing or the other. So that's why I keep saying, do not try to do everything. There's so much to learn. So focus on one thing, know it very well, understand the technology, how it works and all that. And hopefully sometime in the future, the opportunity for you to try another one will come. If it doesn't, if this is the only thing you've ever worked on, talk about it at your interview. It's not a crime. It's actually a very good thing if you can talk about one thing and talk about it very well, about how you've used it, okay? And then it has two ways. Its configuration has two different types of configuration. You can either use the HTTP01 or DNS01. So we are going to be using the DNS01 because we want our configuration to validate, because these two other configuration is how Cert Manager confirms that you own the domain, because it's not just going to issue out certificate to you if you don't own the domain. For example, yes.
Is there any particular reason why we are using ACME for this practice?
Well, so the reason why I have chosen to use this is because that's what we use at Diary.io. And I've used it for many other projects. Okay, so it's used widely, okay, by a lot of organizations. The other one that I know that organizations use is Vault. Very well. So once you've worked with one, you can always work with the other. So you can make it a point of practice for you to try other ones. It's just about going through their documentation. That's it. Okay.
So another question is, everything is called, holistically, they are called Cert Manager, right? Or what would you refer this Vault Venati to be?
So these are issuers of the certificate. Okay, these are issuers of the certificate. So what we're going to do, we're going to talk about the architecture shortly. I just wanted to quickly set some understanding ahead, because we'll still talk about how it was the whole issuing, what happens behind the scene. We'll go through all of that shortly. Before your question, what I was trying to make reference to is the fact that when you are configuring Cert Manager to issue certificate for your domain, it has to be sure that you own the domain. Because if you have talkware.com, for example, I'm not going to deploy Kubernetes and ask it to always generate certificates for me for your website. Okay, that's not going to happen. So how is it going to be sure that you own this site? One of the ways is if you have servers configured for Diary.io, for example, you can use the HTTP01, whereby it gets to go to your site and then it drops some text on there. And if you're able to confirm the text that it gets to drop on that server, then it knows that you own it. But the most elegant way that we use a lot is the DNS one, because that way it's going to connect to your AWS Route 53 and it's going to drop a TXT record. So once it's able to do that in your hosted zone, it confirms that yes, you own the domain, and it will go ahead and issue certificates for that domain. Because when issuing these certificates, remember, the certificates will have the exact host address in it. If that certificate does not contain that host information, right, it will not work. Your sites will not, it will just be insecure. It would just tell you it's not valid, it's just not going to work, because it means that you don't own that that certificate, you can't use that certificate. Okay, it's going to give you all sorts of errors. So the cert manager tool will ensure that the certificate that is being issued will have your host information. But for it to do that, it has to confirm that you own the domain. So now let's quickly talk about a bit more about its architecture. Okay, so what happens is cert manager gets deployed into the cluster. Okay, and then it issues certificates for your website. So for example, you can see for this example here, the issuer is Benafi, and let's say it's Benafi-TPP, that's the name of the site. Oh, sorry, it's fullbar.com, that's the name of the site. It retrieves the certificate from Benafi, okay, Benafi, and then cert manager issues the certificate for your domain. Now, the same thing applies if what you've configured is to use it with Let's Encrypt. Okay, so your www.example.com or whatever.com it is, it gets the certificate from the issuer, and then you use that certificate to sign new certificates for all your websites. Now, this certificate gets stored as Kubernetes secrets. I'm sure by now you are familiar with Kubernetes secrets. So it's another resource in Kubernetes that Kubernetes uses to store secret information. Of course, you know that secrets in Kubernetes are not entirely secret because they're just an encoding. So, but that's the way they've designed it at the minute. Whether that's going to change in the future, I don't know. But for now, that's how it is. I think there are some open source tools. I was reading on one, I think, a few days ago that is solving that problem. It allows you to store your secrets in Kubernetes, but it's actually proper secrets. And that way you can keep your password in your Git repository and it's fine, it's secure. But I haven't tried that. But for now, you should just understand that when this certificate is issued, the way it is stored in Kubernetes is in the form of a key pair secret, okay? And you'll get to see that shortly. Conceptually, just understand it for now. So you have cert manager in the middle, you have the issuers right there, and then they issue the certificate for you, which eventually gets stored as secret. Okay, so in the case of Let's Encrypt, the root certificate for Let's Encrypt is actually called ISRG root X1. So if you search in your keychain, that's what you would find. So if you find this, that belongs to Acme. Okay, so that's the root certificate that Acme uses when you're working with Let's Encrypt. Okay, so on a much more high level, this is what happens. So you have some CRDs that gets deployed in your Kubernetes cluster when you install Cert Manager. So to install Cert Manager, you can go to Artifact Hub. You can find Cert Manager. And I'm sure this is now gradually becoming a piece of cake to you. Okay, so let's search all. Let's see, verified publisher. Let's see if official works. Okay, that's fine. Okay, so there's two Cert Managers. So this is definitely going to be the one that we're interested in. So it was updated 24 days ago. And you will see the instructions on how to install it. So you add the repo and then you install Cert Manager. Okay, so once you do that, it's going to ensure that Cert Manager is ready for you to start using. For you to use Cert Manager, there are a few things you need to understand in terms of the issuer, cluster issuer, that we'll talk about those shortly. But as part of this documentation, there's something here that you should pay attention to, which is you have to apply this first of all, so that it will install some CRDs in the cluster. This CRDs allows you to then run things like this. Let's see. Okay, I'm still having issues with this thing. Let me exit this. It says unable to connect to server. I'm sure that's relating to my network, but we'll come back to that later on. For now, it's not a big deal. You understand what we're trying to do? We're trying to remove that cluster load balancer. We'll see where we are with that. But anyway, now, once you have Set Manager installed properly and you start making use of it, you can actually start running things like kubectl get certificates.
Hold on. Hold on.
Yes.
Please, I want to ask, what's the meaning of this? Yeah.
Yes, I'll talk about the CRD shortly. Okay. The full meaning is custom resource definitions. Okay. And what it allows you to do is to have, it's like having an abstraction within your Kubernetes cluster that allows you to create custom resources. That's why it's called CRD, custom resource definition. By default, when you install Kubernetes, it doesn't have a resource called certificate. Okay, the kind of resources that come with Kubernetes by default will be things like pod, deployment, stateful set, ingress, service, all those things. Those are resources that come with Kubernetes by default. You have PVC, have PV, all those things. But now we want to start talking about certificate management. Kubernetes does not do certificate management by default, and you want to be able to do that. So a tool that allows you to do that is Set Manager. But for Set Manager to do it effectively, it then has some custom resource definitions that it will deploy for you so that you can now start running things like kubectl get certificate. And then it can show you, okay, now these are the certificates you have. You can explore them, you can describe them, you can do all those kind of things with it. So that's what a CRD does. So we can actually have a look at what it looks like. It's usually a very long documentation of YAMLs. Okay, it wants me to download it. So what I'm going to do is I'm going to download this. I've had it downloaded before, so I'll just replace and open it up for you to see. Where is it? Oh, there it is. So this is an example of a CRD. So it's also YAML. You can see the kind is custom resource definition. Okay, it has its own metadata, labels, and all that. The app that's using it is Set Manager. But this is what will allow you to do things like get certificate, get issuer. It has, you can see there's issuer here, get cluster issuer. There's a few things, and it has some very, very, very verbose configuration. It's a very long thing. Now I can assure you, this is not one of the things that you will be, the chances of you writing a CRD, okay, is probably 1 to 2%, right? So don't be scared to start wondering, oh, am I going to have to learn this? And, I mean, of course, if you're curious, you want to learn how to write custom resource definitions and all that, you can obviously do that. You put on YouTube, there are tons of materials on how to do that. But these tools like Set Manager, and there's so many of them, they come with things like CRDs. Even Ingress Controller has its own CRDs as well. And if you go into Kubernetes, let me bring it up. If you go into your cluster and you do kubectl get CRD, let me drag it up because there's going to be a lot of them. You can see there is a whole lot of them. Okay, a lot of them. So this is an example of a CRD that has been created and deployed as part of your installation of Set Manager. So if I search this now and go into this file, you can see this is the custom resource definition here. And this is the part that handles certificate request. And this will bring me to this part of the documentation whereby when you're requesting for certificate, this is the process it goes through. Okay, you have a certificate request, which this CRD takes care of. It's going to issue a request to the issuer. And then it creates another resource, the certificate order. I believe there's going to be another CRD for that. Let's see. Probably down somewhere. I think I saw it. Oh yeah, there it is. Orders.acme.setManager. If I search for this in here, you can see it's there. Okay. So it goes through the order and it goes through the host challenge. So that's the challenge I was telling you, that whether you're going to be using DNS01, HTTP01, it goes through a certain type of challenge, which you get to configure. And we'll see all that configuration in YAML now. And then eventually your certificate gets issued. So once you have your certificate issued and you have Set Manager in your cluster, you can then start running things like get certificate. So an example of some certificate that I have requested previously, let me see if it's in my namespace. Okay, there isn't anyone there. I have another namespace called tools. You get to see. Oh, no, it's not there. Okay. Okay, I probably deleted them. But anyway, we'll get to create ours now. Oh, wait a minute. Maybe get certificates. Okay, no, that's fine. Anyway, we'll go through that now. So now that we have that understanding, what we're going to do is to actually have certificate manager.
Sorry.
Yes.
I'm so sorry. So if Vault and Acme is the issuer, then what would you call let's encrypt?
Sorry, can you take that again?
I was wondering under what category we're gonna call let's encrypt. Like, when we talked about, let me put it like this. When we talked about Vault, when we talked about Acme, you said they were called certificate issuer. So I was wondering, let's encrypt. What do you call it?
Okay, I see what you mean. So, okay, basically, let's go back to that. Where is it? This one, right? Okay. So you see, Let's Encrypt is actually a client implementation for Acme. Okay, so Acme is it's the technology behind the certificates issuing itself, but it has to work with certain clients. So Let's Encrypt is one of them. There is certbots as well. Actually, let's search for that information online. Okay, so if I search for Acme clients, you'll see that Let's Encrypt is one of them. So let's see this one. Let's search for Let's Encrypt. Okay. So certbot, the official Acme client recommended by Let's Encrypt. Okay. So anywhere you see Acme, in fact, probably maybe Let's Encrypt is even the name of the company that implements the whole Acme thing. So I'll send this web page to you as well to go through it. But if you notice here, it says Let's Encrypt uses the Acme protocol, right? So Acme is actually the protocol that it uses to verify that you control a given domain. And it works with certain clients. Okay, here it says a recommended client certbot, right? Now, I think it was project 7 or so where you had to use Let's Encrypt with Nginx. And you had to run some tools on the on the server, some Python CLI on the server. Certbot was one of them. So what it's doing there is it's interacting with Let's Encrypt using this Acme protocol. So in this case, rather than say, oh, we're going to be working with Certbot, what's going on here is that Cert Manager is now acting as a client in this case to talk to Let's Encrypt. So Let's Encrypt is the issuer. It's just using the Acme protocol, basically. So don't get it confused. When you see Acme, you know definitely it's talking about Let's Encrypt. Okay?
Okay.
All right. So now what I want to talk about is how to start using Cert Manager. The first thing you want to do is to create the issuer, because there's a resource you can create, which is the cluster issuer. So you have the options to create a cluster issuer, or you can actually create an issuer which is scoped to the namespace where it's created. Okay, so in some cases, you get to create a cluster issuer. If you create a cluster issuer, that means that across the entire cluster, this issuer named Let's Encrypt prod will be used, right? Okay, so this is even not correct, because if I specify namespace here, it defeats the whole purpose of it being a cluster issuer. So I'll get to update this documentation, but basically it's not scoped to a namespace. It's actually global to the cluster. But the other one is the issuer. So if you remove this cluster here, you can actually create an issuer. In that case, you can put the namespace, and anytime you want to use it, if you're in a different namespace, it won't be able to use that issuer. Okay, now, if we go to the spec configuration, this is where you then determine which issuer you want to use. So we're using the Acme protocol here, and the server is going to this Acme v02.api.letsencrypt.org, and all that. This is being provided by the website that is providing the service themselves. So if you go to their documentation, you actually see you have to use exactly this URL. Okay? And then it has some other configuration, email, the private key ref. So the private key that is going to be stored in your cluster, this is what it's going to give it. It's going to give it a name. And then these are the solvers. So this is where you get to configure your DNS. Okay, so what is the domain in question? How do I connect to that domain? So I'm using DNS01, root 53, and we put the region configuration and then the hosted ID. So the hosted ID of your domain, you put it there, which is an information you get from AWS. Okay, so how do we get let me see if I have my Amazon console open. Actually, let me see if I can log into this. 1 second. Oops. Okay. Apologies for my internet. Any question while we're waiting so that we can deal with that? No question. Good. All right. So let me search for root 53.
Sorry, are we going to get a video recording for this lecture and yesterday's lecture?
Yes. So if you haven't received recording for yesterday's lecture, you will definitely get them both together.
All right. All right.
I believe it's still recording. I hope it is. Can someone confirm if it's still recording?
Yeah, it is.
Yeah.
Okay, good. Thank you.
Can you hear me?
Yes.
Hold on. Yeah. I want to ask, if some site like
Are you someone asking a question?
okay, I'm saying that I saw something like about these TLS that says they're using Nginx to terminate TLS. So that terminate now is confusing me. Like that
Okay.
is using Nginx to
Don't worry,
terminate.
I'll explain. I'll explain it to you. I'll explain to you shortly. Okay. All right. So this is where you get the hosted zone ID configuration. Okay. So you can just copy this and then put it here. Now, one thing you should bear in mind when you're configuring your cluster issue and you're using DNS like this, your worker nodes running your cluster, they must have IAM permissions to connect to root 53. So you may have errors in your logs that you can't issue certificate because this part of the process couldn't be completed, host challenge. If it's not able to go into your root 53 and create a record like you would see, oh, actually it will be here. So you see a TXT record and we'll get to see when we deploy anyway. And then you see something like challenge, it gets created in here. So your worker nodes should have either IAM policies attached to them as an instance profile so that it's able to then communicate with the root 53 and then able to do that host challenge. Okay, so you have to bear that in mind. All right. So yeah, we've talked about all this Acme configuration. Now, another thing you should bear in mind is this directory URL for Let's Encrypt. Now, they have production and non-production. That's why it's important to be careful when you're setting this up. So you can set your environment up for production. For non-production, you don't want to use the address for production. They actually have a staging equivalent of this. So you can have a cluster issuer dedicated for production, and then you create another cluster issuer dedicated for non-production. They're both going to be working fine, issuing certificates and everything is working fine. But what the guys at Let's Encrypt don't want you to do is to always request for certificates unnecessarily, bringing down their servers. If you're testing, like we're learning right now, and we're testing this tool, we're trying to see things, there's a high chance that you'll be hitting their servers multiple times. And they want to limit that. So they put a hard limit on the number of requests that you can actually have to this endpoint. If it hits that limit, you won't be able to generate any more requests, any more certificates. You probably have to wait for maybe, I think it's 24 hours or 48 hours or something for that hard limit to be reset. So bear that in mind when you're doing this. So how to get the location, actually, let's go to the documentation. Okay, so you can see this is the staging URL. So HTTPS Acme staging. So this is fine. There isn't a hard limit on this. You can use it for non-prod. They are fine with this. But the moment you're configuring for your production, you want to make sure that you don't use the staging one, you actually use the production one, okay? So that's something to bear in mind. You can use whatever email here. So what's going to happen with this is anytime your certificate is approaching expiry, you will get an alert without you setting up any kind of monitoring. It does the monitoring for you, you get an alert, but you still don't have to do anything. It's just informing you because before the expiry, Cert Manager would ensure that new certificates are issued and they are created properly as secret in your Kubernetes cluster. Okay. All right. So now that we have all that information and we know how to set these things up, so let's go to the next slide or the next documentation to now see an example of how the YAML would look like for your ingress. So you deploy your cluster issuer, you would then add this annotation to your ingress. Set manager.io cluster issuer, you specify the name of your cluster issuer, which is the one that's specified previously. Okay. And remember, this was done yesterday to work with the Nginx ingress controllers. So now you're beginning to see the whole purpose of annotation. So you use annotations to expand the functionality of your YAML configuration. So if you want to work with some other third-party tools, they have their own annotations, you know, from their documentation. You can put it in and your systems will work dynamically as you want them to. And then you set up the TLS section. So you specify the host. Now this host has to match the domain that's obviously been confirmed. So if you have put the hosted zone ID correctly, it will just go in, ensure that this DNS already exists. Okay, then it will just create the certificate for you. So the certificate that gets created will be created as secret. Remember, we talked about that. So the secret name that will be created is what you specify here. And if you open up the secret, you will then see your private key and the public key that's been generated. Okay. Now, this brings us to termination of TLS. Okay. What this means is your infrastructure, I take that back, not infrastructure, your application, I was going to say your application. Your applications are running in pods. And you know, you have a cluster IP-based service that connects to your pods, okay, which is this one right here, okay? This service is running on HTTP because you're reaching to this service on HTTP. It is not HTTPS, okay? Now, TLS termination talks about which endpoints you get to that terminates TLS, that from there going forward, communication is no longer going to be based on TLS, it's going to be based on clear text. In this scenario, your TLS termination happens here. Once you get to your URL, tooling.artifactory or whatever, which is going to be based on HTTPS, that is where the certificate exchange and the whole tunneling, encryption, and everything happens. But you know, your request hits this endpoint, but then it still has to go ahead to your service, which then goes into your port to get the response back. Okay. So if you had HTTPS on here as well, that means TLS termination is not happening here. It still goes further and gets to terminate here. So that's what it means when you start seeing things like TLS termination. It's basically just saying at what point does TLS communication end? Okay, so it will be like an overkill if you have TLS here and you also have TLS here. I mean, there are requirements that would say, yes, everything has to be TLS. Okay, but in most setups, this is kind of fine. This is basically saying, well, once you get into our network, we're secure. We know we're fine because you got here to this ingress host, which is based on the load balancer that the ingress controller had created. Okay, you get there and all the communication is encrypted. If there was an exchange of password, it is encrypted. So it takes that traffic and then sends that password back into the backend service and everything is fine. The moment this sends request back here, at this point, when it's going back to the customer that is requesting for that resource, everything is encrypted. Even if this is sending messages back to this in clear text, whatever hits this place and is going back out to the internet or wherever it's coming from is going to be encrypted. So that's what the whole termination is talking about. Okay. Now, okay, so these are just notes about differences between annotations and labels. You can read all that when you get to practice this configuration. Okay, and then so now we get to see that. So what I'm going to do now is let's have a look at our cluster issue and our actual cluster. So if I do kubectl get cluster issue. Let's see. Okay. Actually, out of curiosity, maybe I'll remove set manager completely. Helm ls set manager. Okay, so set manager does exist. But while we're waiting for that, let me just find the configuration for set manager. Okay, so we have the set manager configuration here. So if we don't have it, what I'm going to do is I'll just reconfigure this and recreate it. Okay, so let's just copy this. We're going to work on it together. I'll paste this. And then let's encrypt production. Yes.
Hello there.
Hello.
From the YAML file, I can understand that is it that you can specify more than two DNS zone, two hosted zone. That's
Yeah.
issue.
Yes. So anywhere you see things like this, it's lists. Anywhere, any configuration that you see that has this hyphen right here, it's definitely list. Also, what it means is it can take multiple entries. So in this configuration that I have right here, I actually have solvers for different domains. As you can see, there's one domain here, Devops Masterclass.link, and this is another one here. Okay. So, but just to remove confusion, I'll just remove one and keep it simple. Okay. So I'll just leave everything as it is. Okay. And let's see if this is going to work. And let's remove this as well. Getting an error. Certificate is valid for set manager webhook, not set manager. Okay, let me see if this was done is actually correct. Let's try again. It might be due to the network. I'm not sure, but let's see. Yeah, it says timeout. This is relating to. Okay, hold on. What's this? Okay. Copy the- Yeah, another thing that could be the problem with this could be the search manager. Yes. Let's see what version of Set Manager is installed, because it's been a while since I installed this, so maybe it's old now. It's been here since March, so what version? 171. Okay, so let's go to Alpha Home. Might be so. Get this. So there's 1H2 now. Let's do Helm repo update. This is taking a long time. Okay, so what's going to happen is if we don't get set manager to work today, that's fine. We'll get it to work next week. But what I would want you to do is to test this out on your own. Okay, so it might be down to my network, it might be down to a lot of things which I'm not sure, but you can go through the installation of this, okay, and then get the cluster ensure installed. Once this is installed, the next thing we're going to do is to go into our Artifactory Ingress. And that will then mean to update this here. So the Ingress will have this annotation. And this has to match the name of the issuer. So whatever name the issuer is given, it has to match it exactly, okay? And then the other part is this. And this has to be like this. What I like to do is just to even name the secret exactly what the domain is, because that helps when you have a lot of certificates, you just want to know which one is what, has to be named correctly. Because when you do kubectl get certificate, you get a list of certificates like this. And then if you also do kubectl get secret, you also get secret back like this, which helps you to know that this secret belongs to this certificate. Otherwise, you can have a bunch of different things. And because they're encoded, even when you do edit or you get the YAML back, it's hard to tell what is what if you don't name them correctly. So this is a very, very important thing to keep in mind. Because you don't want to start running base64, decode, get the actual certificate in the form of begin and end, and then you take that, you run things like OpenSSL commands to see the content of that certificate. That's so long. So you save yourself a lot of headache by simply naming things correctly. Okay. So once you have this, then you can redeploy this. If this was working fine and we redeploy this ingress, what you will notice is you now begin to see things like this. You will see certificate request, certificate order, the host challenge, issue certificate. Let's see if this gets to work. It doesn't look like it's going to work, to be honest. But by the time we meet again, I would have deployed the whole thing. At least today you have the whole concept gotten. I would have deployed the whole thing so that we don't have to wait on getting things deployed like this. And then we'll go through the YAMLs, we'll go through the resources that gets created, because one thing I definitely want to show you is all of these processes, because this is where you're going to get stuck. This is where you're going to spend a lot of time. You can spend a whole week troubleshooting this and your certificate will never get issued. So you have to understand the thought process that goes into investigating what may be wrong, because then you have to know, do I do get certificate? Do I do get order? Do I do get certificate request? Because each of these resources, you can actually do kubectl get on them and then do kubectl describe on them, which is essentially just like going through the logs of your application. But in this case, there is no particular application you have to go through. There's no particular pod that you need to go into its logs. Yes, Set Manager has its pod. You can go through its logs there, but it's better to actually start from the resource that gets created as part of issuing a particular certificate. So once you go through all that, and sometimes you may then want to say, okay, let's go into the pod of the Set Manager, see what's getting reported in the logs. but most times you probably wouldn't even need to do that. When you do your describe on all these resources, it tells you what may be wrong. It could be down to the fact that your worker nodes cannot connect to AWS to do the host challenge. You get to see all that information. Okay. Well, this is where I'm going to stop tonight because, this is definitely hitting into our time and we don't know what's going on. A lot of timeout issues are going on, but at least we're heading somewhere with this. Ultimately, once your certificate is issued, you will see things like certificate is valid. And when you refresh your page, you'll be able to see this whole red thing, they will go away. So next week, once we have this set up, it becomes easy for us to do for Jenkins, for Grafana, for any other application that you want to do. You just replicate the same thing, copy paste the ingress and just use it. Although I'll show you how to then use your Helm without having to configure ingress like this. Because within your values file, you can actually have all those things properly configured. All right, cool. So any question, guys, this is where we're going to stop today. And then from next week as well, we'll go into Artifactory, configure our repos, and start setting up our pipelines.
Hello, Darren.
Hi.
Hello, Darren.
Yes, I can hear you.
Just like deployment controls replication of pods. I'm trying, like if you delete a pod, it will create back because of the deployment object. I'm trying to know the one for certificate because I'm trying to delete one particular certificate. When I do get on it, it keeps on recreating again. Because there is something I wanted to try on the cluster.
Do you want to share your screen? Because I don't quite understand it.
Okay, I've already, it's not online.
Oh, you
now.
don't have it?
Yeah.
Okay.
I just stumbled on the issue because anytime I delete the certificates, if I do get on it, it keeps on recreating again. So I don't know, maybe there is some object that is controlling it. I'm trying to understand, but I couldn't.
Well, because it doesn't have the whole concept of replicas, like you try to compare it. So it's not like deployment that controls the replica, and then the replica will always get created because you've set the replica configuration. The certificates don't work like that. Okay, if you delete the certificate, it should get deleted. So if it's not getting deleted, then it's probably because you are issuing it through the ingress. So did you configure the ingress to provision the certificate?
I think I'm just following your project, that project 25. So I stumbled on that program that you talked about the worker nodes having a
Permission.
Permission. So I later resolved it, but because I didn't have a snapshot of that problem, so I was trying to recreate the problem again by deleting the certificate. So why deleting the certificate? If I do get on it, I noticed that it creates back again because I was checking the age, the duration. It kept back, it kept on recreating. So because I was trying to recreate the problem.
I think it's probably going to be a retry attempt from your ingress because your ingress will still have the TLS configuration. And maybe it's just retrying again. Okay, so the best thing to do will be not to delete the certificate, but actually to try to fix whatever problem is having that is not getting that certificate to be issued.
Okay.
Because what are you trying to achieve by deleting the certificate? You didn't create the certificate yourself anyway. You're not the one who issued the certificate. You're powering it through the set manager and your ingress that has the annotations for the set manager. So trying to delete it is like, deleting the work of the ingress and the set manager, and they may already have retries configured as part of how they work. So if it does another retry, it will then try to issue the certificate again.
Okay.
So that's what I can think about.
Thanks.
Okay.
So, all right. So, real quick, I have a question real quick. So how do you, if you have a domain name, right, does AWS provide services where you can create an email address with your domain name? Do you know? I don't think
can you say that again?
Yeah.
Can you say that again?
Does AWS provide services where you can create an email address using your domain name?
Okay, you mean like AWS?
Like the way you have direct.io, right? And let's say you want to create using your name, your first last without your last name at
whether they provide mail services. That's what you're asking for.
Correct.
Yeah, I think they do actually. If you check out Amazon Simple Email Service, something like that. I'm not sure. I haven't used any of such email services with Amazon, but I know they have some solutions around emails and all that. So you can just Google Amazon Simple Email Service and read about it, whether it fits into the problem or the description of what you want.
All right. Thanks.
Rodari,
Yes.
for practice, can we get the videos for this weekend so that we can work on what you did today?
Yes, I'll get the team to prioritize that for you. Don't worry.
Thank you.
Okay, cool. All right. So if there is no more questions, then I guess I'm going to say have a splendid week ahead.
Hello, Dari.
Yes.
This is different from the class, but I mean, I was just going to ask you some personal questions regarding doing interviews, and I'm not sure if this is okay to ask right now. Maybe just one or two.
Yeah, that's fine. If it has to do with interview, I'm sure everyone will benefit from it.
Yeah, so like, can you just run us like on a day-to-day, because on a day-to-day, like what you do at work, like what kind of projects do you work on at work? Like what kind of tickets you get on a daily that you work on that can be easily discussed in interviews that would look on. I'm sure this what we do right now, the major projects that we can say, okay, this is what we are trying to build. But on a day-to-day, what do you like work on? What kind of projects do you work on that are relatable to what any one of us can talk about?
Well, okay, so the way you can approach things like this is, every project is a candidate for tasks that you'll be doing on a daily basis. What I mean by that is most teams either work on Scrum or Kanban type of project management. If it is Kanban, it's more of as work is coming, we just pick the ticket, we work on it, put it in progress, done, go back in the backlog, pick another ticket, you keep going like that. There isn't any concept of sprints, there isn't any concept of planning what we're going to do for the next 2 weeks. It's always just going, in and out. So what you can say is to start from whether you're working in a support type of team or you're working in a project type of team. If you're working in a support type of team, what you're essentially doing is probably supporting what is already in production, okay? Because even though you have your applications in production, there are support requests that get to come in from time to time. These support requests could come in from the users of the system. It could be from developers, especially from developers and testers, because DevOps engineers work with developers and testers and all those guys a lot. So it may be a case where they have a new test suite they want to add into the pipeline, and they raise a ticket for that, and you help them add it to the pipeline. Or it might be a case where they're trying to use Jenkins, they can't log into Jenkins, there's some network issues, the application is failing, they raise a ticket, anything can happen. It's all support. So once these tickets get raised, you go into the backlog every day. It could be anything. Maybe a Jenkins job has failed. They go out to DevOps. DevOps picks up the ticket, goes into Jenkins, look at the logs, look at the job itself, what's failing, why is it failing? You update the ticket with your findings, you fix the problem, you move on to the next ticket. So that's a support type of situation, okay? Now, if you work in a team where it is more project focused, then we're talking about an example of what we're doing. If it was a project given to a team to say, well, we have a new application that's coming up, we don't have an existing Kubernetes cluster, we need to have a design, how the cluster is going to be, what sort of networking do we want, where is it going to be, what VPC, what subnet configuration, what are the firewall rules that we need to consider, what backend database is it going to be using, how we're going to provision it, what's the CI pipeline we're going to have, what tools are we going to be using for monitoring, logging, a lot of conversations start coming up, and all that will be split into several tickets in the backlog. So there will be like a product owner. A product owner could be a solutions architect or a lead DevOps engineer, or someone who is probably the head of whatever project we're going to be doing. So this person then prioritizes all the work that's been identified. So based on the priority and also based on the velocity of the team. So the velocity basically means the so for example, if the DevOps team is just 2 people, the number of tickets that 2 people can do within a sprint, which is usually 2 weeks, is different from the number of tickets that 5, 6, 7 people can do. So the velocity of the team is based on how quickly are we able to finish all the tickets in the backlog. So for very huge projects, there's going to be a whole lot of tickets. I mean, we're talking about set manager deployment now, cluster issuing, ingress configuration. We can then pick up other things like how do we automate our testing, what testing tools are we going to be using, scanning of our Docker images, when we have vulnerability issues, how do we deal with them? There's so many things that the team will discuss, and the product owner and other people will be creating tickets. Even you as a DevOps engineer, if you feel like there's something that needs to be done as part of the project we're doing, you can create ticket, put your description there, and So during sprint planning, the whole team comes together and then we plan the sprint. So based on the planning of the sprint, based on the velocity of the team, we know that as a team, we can only put in a total number of tickets that has maybe 22 points. So each ticket will have their own point. So if one ticket has maybe 1 point, another ticket has 3 points, another ticket has maybe 5 points, you add 5 plus 3 plus 1 together, that's what, 9. And if we're still going to velocity of 22, we put in ticket for that sprint that will add up to the total number of velocity. Once we've achieved that, the next thing is for the DevOps engineers to go in and start picking up tickets. So those tickets are going to be based on what we have set out to achieve this sprint. So this sprint could actually be focused on ensuring that we have ingress controller deployed, TLS terminated on the ingress, and we have set manager deployed to ensure that all our endpoints are nicely terminated on the ingress with TLS and all that. So splitting all that tasks together, like I'm trying to show you guys all these things now. Normally, these are going to be tasks that will be split across different people, okay? Depending on how many applications you're also supporting. Even this process that we're going through and we're running commands on the terminal will normally go through a pipeline. So someone will be in charge of the tickets that has to do with the pipeline of what we're doing. You know, so that is going to be highly dependent on the project at hand. So you come in every day, you pick up your ticket, you go on. Some tickets can lead to creating other sub-tickets, because at the time of creating the ticket for your work, you probably didn't realize some other dependencies that will come up to you. You only realize them when you start working on them. Maybe there's some dependency on another team that handles network, and you try to deploy set manager. Just for a typical example of what happened this night. Imagine I'm working in the company, I'm running Helm upgrade, and for some reason it's not installing. I'm trying to install the cluster issuer, it's having timeout. And I figure out the problem has to do with networking. Maybe there is some firewall changes that has occurred, or it could be anything. Now, that has caused a different kind of risk to our deliverable for that sprint. So in that situation, what happens will then be, you then create a ticket for the network team. So if that's going to take them 2 days to fix, you don't sit around doing nothing. You go back into your sprint, and then if there's any other available ticket for you to do, you work on it. So that's how things go. I hope that helps.
Yes, it does. It does.
All right, cool. Okay, so if there isn't any more, I wish you all the best for this coming week, and then we'll meet again next weekend. If you haven't learned, watch your videos, projects, you still have the whole of this week to do that. For those who are new, coming in fresh and all that, you know, if you haven't subscribed to the platform, reach out to support, try to understand what your options are in terms of payments and all that. So, and then we'll see you in the class, and then you can get started from the basics onward. Okay. Thank you very much, guys, and have a great night.
Recording stopped.
Thank you.